Center of Energy Efficiency at SEDA. He has more than 15 years of experience in energy and facility management. His expertise includes green township, low carbon cities, common carbon metric, energy efficient building design, and many more. Without further ado, please welcome Mr. Steve Anthony.
Thank you very much. Well, my topic is more on low carbon building, green building, which is continuity on the green pass, the low carbon system that has been presented by Engineer Haji Mokhtar this morning. Because I believe that I wasn't here in the morning. Green pass actually is the assessment system, but it's not really tell how what I call this system can influence the design of building. So some people thought that green pass is not a design tool. It can be used for design tool as well. Okay, for my presentations, low carbon building. But what is low carbon building? Actually, low carbon buildings already exist many years, and some of our building in Malaysia already have doing this. But that time, low carbon is not popular. Carbon started popular when this green technology program, what they call promoted by the Prime Minister, and then low carbon is actually solutions to the climate change problem, as well as the part of the green technology recommendations or solutions. So low carbon building is similar like green building. I think I don't want to elaborate further what is green building, because there are a series of awareness for green building have been done in the country by what they call many professionals, university, academy, GBI, GBC, and so on. The difference actually is the low carbon building, they use carbon as metric or reference in terms of measurements or in terms of calculation to achieve the actual environmental impact, and not based on point collected. And internationally, they already have kind of standard. It's not a standard yet, but they call it protocol. United Nations Environment Protection, Sustainable Building Construction Climate Initiative. They developed this common carbon metric. So they use carbon as a reference. Why carbon? Because as I said, it can be measured, it can be become a reference, straightforward, transparent, means everybody can calculate. If you have the data, you can calculate directly. In fact, if the design, the performance of building, you have the data, you also can calculate. Even your house also you can calculate. Easy to implement because it's very focused on carbon performance. Consistent, easy to monitor since it's based on actual performance. Measurable, recordable, comparable, and also can be justifiable and easy to prove. Because sometimes people say, "Oh, green is green." It's difficult to prove, but using carbon, because it's engineering calculation. Cheaper, affordable, since it's straightforward, focus on the relevant criteria that have high impact, means, and also now it's a global trend to go for low carbon building. Low carbon building consists of, similar like a green building, consists of technology and also human. These two elements, either from the technology part or from the human part, habits and so on, it contribute to reduction of carbon, either is from the embodied carbon during the construction or the material that have high content of energy, water use, or during operation to produce the materials, or during the operations of the building, means mainly actually is energy and water and waste. So the total impact of the reduction will help to make the carbon or the buildings perform with less carbon emissions. So this is overview of green building in Malaysia. And then what Haji Mokhtar CIDB presented, there is a what they call it, the green pass. In fact, in Malaysia, other than green pass, Green Tech Malaysia, they have their own system. They call it BCIS lah, Building Construction Ecosystem. You kick in the data, you'll be able to get the assessment of the carbon using a cast-built carbon for assessment building engine, which is similar, actually derived from the carbon metric. So carbon exists is most of the green building criteria. The main one is energy, because when you use energy, power plant there, they produce carbon and emit to the atmosphere. So measures from energy efficiency and as well as renewable energy have impact on carbon emissions. Same also water, because when water we use involve a lot of process, like for example clean water, for example. So the water treatment plant, they use a lot of resources, especially energy and raw water to process some chemicals, and then need to be distributed by pumping system and so on. And for the materials, this is where we call it embodied carbon. During the production of the materials, we use a lot of resources, either from virgin resources, renewable, or what they call from non-renewable materials. So a lot of process there. If you're really interested to know about the carbon footprints, embodied carbon, there's another what they call separate topic to be discussed on that. Some organizations doing research on this, like for example CIRIM, Dr. Chen, and I believe that CIDB, CRIM, and some university also doing that. And then site construction is where the materials that used in the constructions involved, they have a content of embodied carbon. In Malaysia, maybe this is not the culture yet, but in overseas they already have that. For example, if you buy cement, they have embodied carbon. Much kilogram carbon per kilogram or meter cube of the material. Same also like, for example, bricks. I went to IGEM expositions last year in PWGC. There are 2 or 3 companies produce bricks, and they have because they are registered for eco-labeling. They have this carbon footprint for that bricks. And then when I asked how you derive that, they work together with researchers. Mainly they take from the energy use as well as the what they call where the materials comes from, and then they calculated the things on that. Indoor equality also have, but this is not very direct. The process that improve or provide good indoor equality, such like a cooling system. For example, the refrigerants, like split unit aircon, they use what they call this refrigerant, and refrigerant have CFC and so on, have conversions to carbon. You also what they call this carbon depletion and so on. Where does the carbon come from? That is another what they call view. This is when we look at the green building criteria. But another view is when we look into the life cycle. Start from the say the resource extractions. There's trees, plants, which is the carbon sequestration, absorb carbon. When the plants do photosynthesis and so on, it absorb carbon to produce what they call oxygens and food for the plants itself. And then during the resource extraction, when they clear the land and so on, this is where first the carbon sequestration demolished. Second is the machinery use energy to do the land clearing. And manufacturing, this is where I mentioned just now, the material used for the building material as well as the construction materials. And on site where the works involve heavy machinery, which is also use energy and water. And during the occupancies, maintenance, where this is where the energy use as well as water use. And after that, when do demolitions, this also involve high resources, energy as well as water and some other resources during the process. And some of the material recycle, and some just throw in the landfill like that. So when they recycle means reduce part of the carbon or resources or energy to produce the new material. So this is where the what they call carbon cycles, the building products. When it comes to building operation, building life cycles, not clear there. Here is not clear. It's a cycle starting from a pre-design, design, development, constructions, and then use and then management and maintenance, and at the end is demolition or regenerations. Research has been done worldwide showing that the life cycle of the building, say 50 years for example, most of the, there's two parts. Embodied carbon is during the constructions, we have mentioned just now, and the second part is the during operations, which is, you can look, that is the biggest part. This is area where operation carbon comes from, mainly energy, water, and waste. So if you want to design low carbon building, means we need to look into the statistic here, where to tackle, so that the design of the building will be what I call focus reduction of carbon. You can have in the embodied, but one embodied is only considering one time, but the one that keep continue is the operations. And when mentioned about low carbon buildings, it's not run away from the technology, as well as the what they call practical or human practice. So green technology in buildings is mostly liquid technology application that has impact to the energy environment related to building services. There is a few phases. First, the design of the building, mainly refer to energy efficiency, to how the building designed to reduce energy, make it energy efficient, and on top of that, we can generate energy from the renewable resources, either photovoltaic. If they have a wind, we can have wind, or biomass like other country, and as well as water management. Because water also have a content energy, as I mentioned just now. When we save water, means we save the process of the water in the plant, because there's a high energy use during processing water as well as the distributions. And then when it comes to when the building completed, then normally what we call it a second fitting. The office appliances is not normally under the designer, it's fall under the user. So the user need to procure or use energy efficient appliances in the office. And operations, where the energy and water management need to be also in the operation maintenance. You can have a very high-tech green building, low-carbon building, I mean the technology part, but if say the operations, the humans part, they're not emphasized on this energy or environmental management, means whatever you invest to the technology, basically it will go to the drain, because very expensive, but the building cannot perform as it supposed to be, because the human part not really interact in such a good manner, so that the building can perform as supposed to be. Same also like during the renovations and retrofit, very often energy efficient building designed in the beginning, but when it comes to renovation, retrofit, because of the users, they don't have kind of energy management or environmental management, so they just renovate according to what they want. And this is where, if the good building, they have like energy managers to advise the users, especially the administrative officer. And the rest is more on the like paper, water recycling, and also good indoor quality and so on. And the last one is the awareness, the energy end user awareness. So this is where factors that contribute to reduce the carbon in the building. And I think think most of you have seen this relationship between energy and environment, the carbon. You heard about the Earth Hour. Lately, the Earth Hour is not like 2-3 years ago where people were very supportive. But now I think I also forgot to read the Earth Hour because the promotions and so on not be done what they call continuously. I remember when during the Earth Hour I was in Malacca, one hotel. So this hotel said they distribute circular underneath. Please close your curtain. Because they don't want people outside from the hotel can see the hotel didn't participate in the Earth Hour to switch off the light. This is true. I mean, even in fact, when I was with Pusat Tenaga Malaysia or Green Tech Malaysia, every week we receive a lot of visitors, especially students, even professionals. When I asked them, did you participate in the Earth Hour? So they said, yes, why? Because we don't want the neighbors see that we are not environmental cautious on that. So switch off the light, but they switch on the aircon, they switch on the TV and so on. Means the idea to save 1 hour lighting actually is to save power generation, the power plant. But during the campaign, not many people convey this message. So yes, they switch off the light, but they switch on the aircon. And then aircon energy use is higher than the light. So this is the thing I think we need to try to convey to the public. So in Peninsular Malaysia, average 1 kilowatt hour electric we use, we emit about 0.684 kilogram carbon in the atmosphere. Means if you save energy, the building is designed to be energy efficient. It is also have impact at the power plant where reduce carbon emissions. Similar to water. In Putrajaya, 1 treated water meter cube is around 0.35 to 0.4 kilogram carbon for 1 meter cube per treated water. I think it's good to have, this is where I also have interest in this. It's good to have a kind of statistic research where average in Peninsula, and we work with Shabas, work with Ida, water or Pucat Niaga and so on, develop what is the average carbon footprint for meter cube per water. For electricity, it's already there under the NRE, which is the Green Tech Malaysia in charge of evaluate this, so come up with this figure. But water don't have here. And this is an example of low carbon building. Carbon building, it's already there. Started with the Leo building. I'm glad to see that my ex-team who involved on these 3 buildings here. I'm not really involved on the Diamond building as Energy Commission, but I'm involved in the conceptual. And the first one is the Green Energy Office building, where I managed this building for more than 3 years. Okay, so when it comes to design a low carbon building, mainly actually is the low energy building. So the designer, even the user, need to understand what the factor affecting the energy consumption in the buildings. It's not just people said I installed this and so on. There must be justifications on the best way to reduce energy. And this is statistic of energy use in commercial building office. We compare it from the energy audit in government building 2003 by Pusat Tenaga Malaysia, where there is about more than 10 energy service company, ESCOs, have been involved in the energy auditing. And in average, air conditions, as everybody knows, use more than 60%, more than 50% of the energy use, followed by lighting and equipment. But lately, from discussion with the energy auditor professionals, the equipment part is increasing. One of the reasons is we believe the ICT equipment and ancillary, which is also the cooling system for the equipment, have been what they call increased portions in building. That's area actually we need to look into, because nobody really look into that. Because when it comes to ICT, I also designed that before. When it come to ICT, there's always a missing link between IT professionals and the M&E or architect. Because when they design the server room, they always follow the requirement from ICT. But experience from international, even Green Tech Malaysia and also KETA, ICT equipment not necessary to be very cool, 20 degree. If the ventilation and the heat rejection system have been designed properly, very clear. And we do the research before we end up with my previous company, organization, Green Tech Malaysia, as well as Ministry of Energy when they retrofit the data center. The server, what they call hub switches and so on, is very clear mentioned operating conditions, temperature. It doesn't require 19-20 degree. It can go up to 35-28 degree. But when we ask the IT professional, I think about when I was doing meeting in one of the semiconductor company who produce chips in Penang, the IT what they call officer said no, must be 19-20 degree. That we set by this is the requirement. But the production engineer said can, because I test my chip 80 degree at zero for 18 hours for the QC. So that is the complete plan. But at the end, what happened is after the discussions, the IT officer was convinced to increase the temperature from 20 to 23 degree. They want to 24, okay, tengah-tengah get to 23. And then I don't know what happened after that, but believe that if you have a proper ventilation, it should be okay. In Green Tech Malaysia, Gregor's Paul was involved in the design. Until now, no problem, 24 degree. Just a split unit inverter Panasonic, 1.5 horsepower to power the server room. No problem until now. This is the energy used for industrial building. Different industries have different portions of portioning. And I don't just what I call touch much on how the efficient design and so on, like the building facade and so on, because I think it will be presented by the next presenters, or maybe it's already presented before. But I want to bring your attention that in building there's two loads that normally happens, occur. Variable load, which is where during the working time, daytime, and also the base load. Base load is actually the load that running 24 hours. Most of the time we design accordingly to the variable, but sometimes we didn't really look into the base load that's running 24 hours. I will share with you what is the items there running 24 hours. What is the culprit there? This is one building in Cyberjaya, 150 kilowatt running high time, including weekend, running 24 hours. It's huge. This is a typical building load profile during the working days. I extract from the building energy audit guideline that we have developed in Pusat Tenaga Malaysia back in 2002. This is library actually. Night time, the black color, actually the total load. So after 5 o'clock, the library closed, but they still have a running some load there. And then after 12, it will reduce. And then we will maintain about 30 kilowatt. When we do energy audit, we found that the 30 kilowatt part of that is pump, the water pump running. Okay, this is the one of the small office in Technology Park. I with my team that time to do the energy auditing. Very small office, partly lab. So the base load is 14 kilowatt, but the pattern is very different, you see, because the user is very energy conscious. If not in the office, the icon they will switch off. That's why the pattern is different. See, like this is like the table, but this is like pattern is like mountain. And this is another building in Klang Valley, also about 140 kilowatt base load. this is the green tech management building. They have learned from the past, from the what they call Leo building and also energy audit that have been done before. They managed to reduce the base load only about 7 to 8 kilowatt. This is a 4-story building, office building, only 7 to 8 kilowatt. And this one negative because they have photovoltaic, so they sell the energy to the grid. And when the building have a high base load, for example, one building in Cyberjaya, 114 kilowatt, what is inside there? So night time we do the energy audit, and then we do a lot of washing. Majority is come from split unit. Split unit that cool down the ICT equipment, servers, the telco, hub switches, communications, and so on. And also transformer. Core area, this is where part of the ICT hub and switches sitting in the core area, because the meter power supply is together with the lighting in the core area. It's running 24 hours. Communication where this is the Cellcom, Maxis servers, also inside the building, the tumpang for and UPS also have high. The reason is high is actually the capacity of UPS is higher than the consumption, because the building is already have low energy in terms of office appliances, but the UPS provided is higher. So when it's not really optimized, the losses is actually higher. It's about 12 kilowatt. And then the data center is about 8 kilowatt. Office lighting equipment is where the car park, corridor, some what they call in the pantry, even in the plant room, ASU, the pump rooms, and then so on. And if you look at this total split unit, this is the breakdown of the air conditioning system. Telco, UPS, and data center. This is the rule of thumb. If your equipment, IT equipment, say 10 kilowatt, your cooling system not supposed to be 10 kilowatt, be less, because if back to energy, what I call conversion, amount of energy used will be translated partly to heat. But if more than that, means some other heat is coming. So means it's not cooling just the equipment, but it's also cooling. We call it ghost. Ghost it's not that which is we will not be able to measure. Okay, lift, motor room, control system, security, PIPX, and so on. This is where. So if you want to reduce the load, base load of building, we need to look into this what they call load that running 24 hours. And when we want to have a low carbon building or even energy efficient building, the first thing that we need is the commitment from the user client. Sometimes client want green building, they want energy efficient building, but when asked why, no, I just want. So if they don't have commitment, then we're going to have problem. First is because by having commitment, they need to have a need statement. Need statement. All the 3 buildings I showed just now, they have need statement, because need statement is kind of policy. The designer, when they design, they will refer to the need statement. And then even the operation maintenance, when they do the operation maintenance, they need to refer to the need statement, because the procurement tender to select the contractor not only does the price or the maintenance, but also element of energy management. Same also the users. When it comes to procurement of equipment, even retrofit or and so on, they need to look back to the disbalance policy, because what is the objective? Otherwise, if they don't have commitment, they're just wasting time, wasting money. And the design must be integrated approach to get the best, lowest possible energy consumption. The 3 buildings just now I mentioned is undergo this process, brainstorming, where all the professionals, including the maintenance, facility maintenance, if possible ICT in the green tech building, the ICT consultant was involved, and user as well. And then normally it's led by the energy or green consultant on this, because we understand that engineers and many architects, they have their boundary. But the green consultant, they don't have much boundary. They can be the integrator of it. Means even if it's good energy consultant because they have experience on audit and so on, they can comment. Means when we mention comment, is all in a good way, not in a negative comment, to improve. Because how many architects, engineers have experience to revisit back the building that they have designed? I went to one of the clinics that we audited. The architect who built the design, she also haven't surprised me. I didn't think I designed this what they call a staircase like that. The staircase without daylight. So there's a 24 hours lighting. So this is good when you have a brainstorming. But of course, it's not a culture here in Malaysia. Sometimes it creates tension within the professional. But at the end, from the 3 experience that we see, everybody is happy because it's a teamwork to achieve that. And then the way the way identify the measures is through root cause analysis, which have an impact. Consider technology as well as human, and then energy performance analysis. All better. Not just simply I want this, I want it. No, all have been justified. It's good if say the energy consultant have the capability to run simulations because they can test what if, and then choose the most appropriate strategies. The cooling equipment, double glazing, radiant cooling, whatever. All this possibility you can test it, but of course they need to be justified in terms of saving the achievement as well as the cost. So selection of design strategies. The selection of strategies depends on ultimate design target. What target you want to? 20% reduction, 30%, 50%, 80%. So the selections of strategies will depend on that. Different building will have different design strategies, depend on the nature, physical of the building. Tall building maybe have different strategy. Bangunan, what they call it, gemuk, different orientation because of land constraint, have different strategies. Any irrelevant measures or too expensive could be omitted because by justifying in terms of economics, maybe the professional can justify that is what they call too expensive or not relevant. And then best to put priority strategy that have high impact, mean high performance impact with low or minimum cost. Because some of the strategies sometimes very low cost measures, sometimes just what they call without playing or dependent much on the technology. It's sometimes a best practice, not even sometimes according to the standard, but best practice. So this example of the new building design, the Ministry of Energy building, also undergo the process brainstorming and so on, and then they come up with their, like this windows design, roof insulation, innovative atrium. Brainstorming normally will create innovations to the design, use of daylight and so on. So this is the example how they derive. For example, if the building is just designed as it is, like conventional, so here we use index because it's easy to understand. Index means the amount of energy used per occupied area per year. So 275. If they use daylight using the simulations, they can get the index reduced to 247. And same if they have good insulation through OTTV or RTV calculations. And energy efficient design of the lighting from 20 watt per square meter down to 16 watt per square meter intensity. Even equipment use energy efficient equipment like motors, pump and so on. Energy efficient lighting design, there is a 300 to 400 lux as per MS 1525. And energy management, this is a process too. I mean, the human part as well the equipment, building automation system, room temperature set point, and also airtight. So 56% reductions have been proved And then if you use green pass rating system, it's equivalent to 4 diamond. This is the real performance. You see the building, and also the building, same nature in Putrajaya. This is the index. It's been monitored. Until now, we still monitor that. And for the green tech building, also have a similar process. And then after brainstorming, series of analysis, they come up with these measures, strategies. You see, the Leo building have different, Geo building have different. And then when the building completed, operated, and then the performance can be monitored, even the carbon conversion and so on. And then from the analysis, if the building design just energy efficiency, it will be able to reduce up to 70% energy. And with the renewable energy, the net saving is 85%. So if you are using the Green Pass rating system, eligible for 5 diamond. This is another example of a government building, 37-story, but the building is quite thin, slim, facing east and part is facing west. So if the building is as it is, using normal brick wall with 90% wall to windows to wall ratio, 6 mm clear glass, so the index will be around 382. So when the designer proposed to reduce the wall windows to wall ratio because want to reduce the heat, so there is a reduction. Even from 6 mm clear glass change to 2 mm light green tinted with light transmission 63% to allow daylight come in, but of course the shading coefficient is 57% to reduce the heat gain, so some reductions. For use the MS1525 lighting luminance in the office plus occupancy sensor, means nobody there, it will turn off. Energy efficient lighting design using instead of just fluorescent, change to T5 for example. And then some area have a penetration of daylight with the sensor, you can see the reductions. Even the office equipment, 10 watt per square meter. High efficient motor, energy efficient air distributions, no losses for the ventilations. Energy efficient aircon system with building automation system, the coefficient of performance at 3.8 instead of lower than that. So huge what they call reduction. Room temperature, airtight building with fresh air control. And then the last one is actually instead of normal bricks, they change to a little light concrete. So this is how the strategy is derived, and then to get the saving 57% reduction. And if you use green pass rating, is 4 diamond. Same also computer lab. All this is our what they call projects. This government computer lab. Also, I will go through the process of brainstorming with the designers, architects, and so on. You know what? The best building original have here we didn't use index. We use the total energy use. 20.97 megawatt hour per year. And what happened is during the audit, we found that some area of the building is not usable. It's not a corridor. If you want to put table, also actually it's not fit for that. It's just additional area, but it required energy for cooling. So during discussions, the architects redesigned the layout, so they are omit a little bit the one that not usable. So this is how they reduce the energy. In fact, also reduce cost. And then instead of using split unit for this, I think there is a 3-4 split unit conventional. Use the VRV type of split unit centralized with a higher coefficient performance. And the computer, last time computer is the bulky one. So they need to propose the additional application. If they want to procure, there must be energy efficient equipment, meaning using flat screen TFT. The roof have insulations in the wall VT. Even the test we have ventilation inside the what they call attic roof. Brick wall changed to 50 mm aerated concrete. And some condition, because this is a template, if the building oriented facing north and south, I mean, to reduce the heat gain directly from the sun, also have a kind of impact. And to bring the daylight, they put additional 2 windows, but unfortunately, when put 2 windows there, the heat gain is coming. So that is the test that they have done. And rewired the lighting to turn off at night. You know why? Because the original design of lighting is, this is computer lab, and there's a projector there. They want to switch off the light in front there, but because the zoning is has what they call done in the traditional way, the light at the back also off, so it's dark. So what happened is normally they zoning it so that if the projector on, the light is in the front there can be turned off, so it saves energy. And then 24 degree for the lab as well as the server room. And they try to use high performance glazing, but actually it's not much because there is a shade already shading there. They also try to test with 100 millimeter of mineral wool, but not much because the 50 millimeter mineral wool just now is already more than enough. And then proposed to set 25 degree of the lab. You know what? This lab have fan. Instead of just they rely on the what they call the aircon, the fan is there. So they increase 25 degree, switch on the fan for only for one speed, which is increase the comfort level. And they have server room, but when we visited several lab, actually what they call server actually is a PC. It's a computer, just the purpose for the internet as a gateway. So you also know that computer is not a high-end server. So most computer desktop can run at 26, 27 degrees. Even at home, you never give aircon. So there is an option. They can turn off the server air condition. And then because of the area of the where people sitting is cooler, so the return air is channeled to the server. So that means the cool air from the lab is channeled to the server to cool down the room. And because of this exercise, the what they call it, the cooling load is reduced from 25 kilowatt refrigerant down to 16. And then 54% reduction. And if using green pass rating is on operation is about 4 diamond. So this is an analysis done using the computer analysis and some of what they call economic analysis. And then they managed to prove to mention that 2.2 simple payback period, a year payback period. For retrofit building, this is the real example warehouse in Shah Alam. What they do is with very simple measures, because they study, understand, do the energy audit, the lighting, they delamp the lighting. Some area using the large level measures is more than supposed to be according to the MS 1525. And they have exhaust fan because the roof, they have exhaust fan to bring out the heat. But what happened during the energy audit? We found that the fan running 24 hours. Night time is cooler, but still the fan is running. So invest what they call this temperature sensor. When set is about 28 degrees. When night time the temperatures reach the what they call, or during the raining season, it will what they call off the fan. Same also the light in the warehouse. Use of the light. Some exit signage change to LED. Awareness with energy management campaign. They have environmental officer. This environmental officer actually in charge of the safety as well as indoor quality in the warehouse. So they send this environmental officer to the energy management course and they come back to the campaign together with the safety campaign, and then they manage to have a safe more. And the high cost measure is they're using metal halide. So after doing the study analysis and so on, they changed to T5 high output lighting, and then they save a lot. And some zoning, because night time they also operate, so they have a zoning where they rezoning so that when the forklift moving, only the area that have been assigned can be switched on. So it's around 50%. If using green pass rating system, it's about 3 to 4 diamond. So it's already a lot of publications you can refer to this energy efficient or low carbon building design. Technology can be used a lot. I put also water. Thank you. That is my presentation. You can get a copy from the organizer. If anything, just give a call anytime, but I prefer after office hours because during office hours difficult to get me. I always have a meeting. Thank you.